Good morning everyone, this is Dr. Srimanta, Assistant Professor in Chemistry, Department of Science and Humanities, MLR Institute of Technology, Hyderabad. So we have started polymeric materials chapter. So this is part 2, already part 1 finished. If you have not watched, then you can watch that before this class. So in this class we are going to learn what is polymerization, addition polymerization, condensation polymerization, and lot of examples like nylon 66, terylene, bakelite, all these things we are going to learn. First point, that is what is polymerization. So if somebody asks you what is polymerization, in simple words we can say the process how one polymer is being synthesized, we will call that process as polymerization. So the reaction of monomers to form a polymer is known as polymerization. The same thing we are writing in a separate way. So now polymers can be formed into different ways. Basically these are the two types of classification already you have watched, you have seen in the first lecture. One is addition polymerization and second one is condensation polymerization. The other name of addition polymerization is chain polymerization, and the other name of condensation polymerization is step polymerization. So step by step we will learn all this thing. So now what is addition polymerization? So from the name itself, addition, what you can understand? Addition means if you just add A plus B, you will get AB as product, means only addition will be there. So here before explaining this addition polymerization, we have to know the conditions. For addition polymerization, each and every monomers must have C-C linkage, CC11 it must have. For example, ethylene, vinyl chloride, propylene, butadiene, styrene, all these things, they can participate in polymerization reaction because they have CC double bond. In this case, the reaction rate will be very high, and this reaction, this addition polymerization involves this mechanism. Mechanism involves 3 steps. One is initiation, second one is propagation or branching, and the third one is termination. So now come to the first step, initiation. So what initiation means? So here we have one peroxide. So from that it will produce radical, RO dot. So this is radical. So now this radical will react with the first monomer molecule. For example, if you consider ethylene, so this is the ethylene molecule. So here you can put H. So just put H and H. So this will become ethylene. So now this RO dot. So this radical will form bond with this carbon, and we will get this thing as product, because this pi bond electron will move to this carbon. So here basically if you just consider step 1, at the end of step 1 means initiation, you are getting one radical product. Okay. So now propagation step. So in the propagation step, this radical is coming from initiation step, and this is our second monomer unit, second monomer molecule. So again this kind of reaction is going on. So whenever radical mechanism we are explaining, we will always use this half arrow. It means radical mechanism. Okay. So this electron and pi bond, each and every pi bond has 2 electrons. So one electron will make bond with this radical, and another pi electron will just move to this second carbon. Again here we are getting radical as product. So this step is called propagation or branching. What does it mean? So this radical is reacting with the second monomer unit. We are getting one radical. Again this radical unit will react with other monomer units. So for example, n number of monomer units are present, so it will react with other n number of monomer units, and we will call this thing this polymer radical. Okay. So again at the step of propagation step, we are getting another radical product. Now come to third step, that is termination step. So termination means where this reaction will end. So here we have two different chains having radical. Okay, so now these two chains, if this radical and this radical combines, then we will get this as final products. And if you just look at this product, there is no radical, so this will be our final product. Okay, so now at the end of termination step, we are getting actual product. So for example, if you consider initiation, propagation and termination, so these are the mechanism, and one real life example is polyethylene. So we have ethylene monomers, so n number of ethylene molecules are present. So these are the conditions: heat, pressure and catalyst. What type of catalyst we are using here? Ziegler-Natta catalyst. So after the end of this reaction, we will get this as product. So always remember, whenever we are writing N, then CH2 double bond CH2 for example, so this is N number of ethylene molecules, N number of ethylene monomers. N, it can be 10, it can be 100, it can be 1000, it can be lakhs or in crores. After that, after this reaction, CH2, then this third bracket, and after this third bracket here we will write N. So it means N number of ethylene monomer units combined and produced this chain, and this is one just single unit. This single unit will be just continuing up to N number. Okay, so this is all about addition polymerization. Now come to condensation polymerization. So here condensation means basically two different molecules or two molecules, they will just form bond. So this is the first thing, and here the condition is functional groups. If you consider any condensation polymerization, the condition is each and every monomer units must have functional group. Now what is functional group? Examples: acids, amines, alcohols, phenols, carbonyl compounds, basically C double bond O, OH or NH2 or OH or phenol or carbonyl, like this. So all this thing belongs to functional group. This is the condition. So now for just consider this example. So this is called hexane dioic acid. How many carbon atoms are there? 1, 2, 3, 4, 5, 6. 6 means hexane, and dioic means 2 acid functional groups are there. Hexane dioic acid. So after that, this is one single monomer unit. This is another monomer unit. It is called ethane diol or ethylene diol. So diol means 2 alcohol groups are there, OH. Now if these two monomer, hexane dioic acid and ethane diol, if they react together, then what will happen? From the color text you can see here OH we have, here hydrogen we have. They will combine and produce water, H2O, and this CO will connect this oxygen, means CO bond O bond CH2. This kind of link we will have. So this is called ester link. So hexane dioic acid and ethane diol, if they combine, they will form ester link, and we will get this as polyester. This is called polyester, and we will get one byproduct, that is water. So now in this condensation polymerization, the role of functional group is that actually functional group is participating and forming ester link, and side product here water as side product, here water we are getting. So whenever we have lots of examples, how we will understand what is addition polymers and what is condensation polymers. So if you see the polymerization technique, so in case of addition polymers, there will be no side product. But if you consider condensation polymerization, there will be one byproduct. There must be one byproduct. It may be water, it may be other compounds, small molecules. So example of condensation polymer is nylon 6,6, phenol formaldehyde. So all these things are condensation polymers example. So now come to nylon 6,6. How we will produce nylon 6,6? Adipic acid. So how many carbon atoms are there? Total this 4, 5 and 6. Adipic acid, total 6 number of carbons are there. Hexamethylene diamine. This is another monomer molecule. So how many carbon atoms are there? Here also 6. So now you can understand why this 6 and 6, these things are coming. One 6 belongs to adipic acid, another 6 belongs to hexamethylene diamine. So now if they combine, just think here OH is there and here NH2, amine, functional group is there. So now if they combine, they will form water. How water? NH2, how can we write NH2? NH, like this. So this OH, it will take one hydrogen of NH2. This OH will take only one hydrogen of NH2 and form water. And this CO will link this nitrogen. So CO is linking this nitrogen. So here basically we are getting one amide bond. CONH, that is called amide bond. So this is the product. This is the final product and it is called nylon 6,6. So n number of adipic acid monomer unit and n number of hexamethylene diamine monomer unit, if they combine, they will produce nylon 6,6 polymers. So what are the properties of this nylon 6,6? So you can see, if you just look at this structure is like chain structure. Okay, this is chain structure. There is no branching. So this is linear structure. Now if you consider this NH and this CO, for example, this is one nylon 6,6 chain. So here C double bond O, just consider chain, and this is another nylon 6,6 chain. So here consider NH. So now this CO oxygen and this NH hydrogen, they can form hydrogen bond, right? Because fluorine, oxygen, nitrogen, they can form strong fluorine, oxygen and nitrogen, they can form stronger hydrogen bond. So here nitrogen and oxygen both are present and in between hydrogen is there, so they can form hydrogen bond. So that's why these nylon 6,6 molecules, they have hydrogen bonds and those are very strong. Because of that, high strength, high melting point, elasticity, toughness, abrasion resistance, good mechanical properties, all these things we can get as properties of nylon 6,6. And another properties is polar. Polar means if there is a charge distribution. For example, if you consider CH, so here basically hydrogen will be delta positive and carbon will be delta negative based on electronegativity. If you consider NH, hydrogen will be delta positive, nitrogen will be delta negative. So if there is any charge distribution, means polarity is there, one part is positive, another part is negative. If we get any polar things, polar bond, that particular molecule will be called as polar, or that particular bond will be called as polar bond. So if you consider nylon 6,6 chain, so here CO, delta positive and oxygen means delta negative, that is polar. If you consider NH, nitrogen will be delta negative and hydrogen will be delta positive. So here also it is polar. So that's why nylon 6,6 is polar polymers. And that is why it has good hydrocarbon resistance. So hydrocarbon resistance means their polarity is very less, polarity is negligible, and for nylon 6,6 here polarity is very high. So anyway, if for example if you consider benzene C6H6, so that is called non-polar. Okay, so you cannot dissolve that in water. Why? Because water is polar and benzene is non-polar. So polar solvent, polar molecule will be dissolving in polar solvent, and non-polar molecule will be dissolving in non-polar solvent. Since hydrocarbon is non-polar and nylon 6,6 is polar, so that's why nylon 6,6 will have good hydrocarbon resistance. Now applications. So in our daily life, nylon 6,6 it has a huge role in terms of applications. So if you consider automotive parts, if you consider textile, industrial components, consumer goods, electrical insulation, everywhere nylon 6,6 can be used. So these are like some pictures. So everywhere in our daily life there are various applications, various areas where we can directly apply nylon 6,6. So that's why it is very important. Now come to the second example, that is terylene. So terylene, this is the generalized word. So how we will synthesize terylene? You have to take ethylene glycol. This is one monomer. Then terephthalic acid. This is another monomer. So now this OH, this is one functional group, and COOH, this is another functional group. If they combine, they will form this ester link, and byproduct, as byproduct water will be released. So that's why this is one example of condensation polymerization. See, instead of terephthalic acid, if you consider dimethylene terephthalate, so in that case, if we are just changing acid group into ester functional group. From acid we are changing to ester, and here ethylene glycol CH2OH bond CH2OH and dimethylene glycol, both are same. If you see the structure, CH2 whole to OH, both are same. Ethylene glycol and dimethylene glycol, both are same structure. Name is different but same structure. Terephthalic acid, this is acid and this is dimethylene terephthalate, this is ester. So my point is, what I am trying to say, if you consider nylon 6,6 and terephthalic acid, there also you will get terylene as product, and if you consider dimethylene terephthalate and ethylene glycol or dimethylene glycol, in that case also you will get terylene. Terylene is a generalized name. So where you will have this C-double-bond-O bond O, this ester link, okay. So and lot of byproducts. So here water and here methanol you are getting as byproduct. So this is also an example of condensation polymerization. Now what are the properties of terylene? So it has very high tensile strength, good chemical resistance, excellent dimensional stability, high melting point, low moisture absorption. Because of that property, we can use that especially in textile and fabrics. So there we can use heavily. Then beverage bottles, then food packaging, electrical insulation, engineering resins. So all this case, if you consider all this case here, we are using terylene. These are the main use actually. Now come to the third example, that is bakelite. So bakelite, this is one example of condensation polymer as well as thermosetting polymer. You cannot recycle this polymer. So how we will prepare, how we will synthesize this bakelite? So first phenol and formaldehyde, these two are monomer units. So this is phenol PHOH and this is formaldehyde. So formaldehyde we can write HCHO or H2C double bond O. This is formaldehyde and this is phenol. If they react together, they will first prepare this intermediate. After that, water will be released and it will form this intermediate, second intermediate. Again phenol will react with this intermediate and form this unit. Again formaldehyde will react with this and replace all this CH2OH group. So basically after this reaction we will get this cross-linked polymer, cross-linked chains as product. So this is called bakelite. So here you can see, here if you just look at this mechanism, so this formaldehyde, this is actually reacting these two ortho position. these two ortho position and para position. After that, water is being released. If you consider the first CH2OH group, this one, first step is water will be released. After that, phenol will react this double bond CH2, and this CH2OH will be converted to this functional group. Again, these three steps, 1, 2, 3, these three steps will be continuing, and this CH2OH, this group will be replaced by CH2PHOH. Again, this CH2OH group will be replaced by CH2PHOH. So after that, this one is the final product. This is called bakelite. So, and here the another point is, one alkaline catalyst we need, that is sodium hydroxide. This is the catalyst. So in case of bakelite, what are the monomer units? So one is phenol, another one is formaldehyde. And what are the catalysts? Only one catalyst, that is sodium hydroxide. And the temperature will be 150 to 200 degrees centigrade temperature. And why it is highly cross-linked polymer? Because you can see this is one chain, this is another chain, and in between we are getting lot of cross-link. Okay, that's why cross-linking polymer. And why it is condensation? It is a product of condensation reaction, because everywhere here also actually water is being released, H2O. Each and every step here water will be released. Each and every step water will be releasing. So that's why this is called condensation reaction. So what are the properties of bakelite? It is very hard, rigid and strong material. Excellent heat and moisture resistance, good chemical resistance, good abrasion resistance, and electrical insulation. So because of this application, we can use this material in various applications, various fields like electrical insulator, automotive components, kitchenware handles, jewelry, firearm grips. So all this case if you consider, so there we can use bakelite extensively. Now what we have learned from today's class, so we have got the idea of polymerization, how polymers are being synthesized. So there are two types of polymerization we have understood. One is addition polymerization, another one is condensation polymerization. Another one is difference between addition and condensation polymerization. This is also clear. In case of addition polymerization, there will be no side product. But in case of condensation polymerization, there will be side product like water, H2O, or methanol, CH2OH. All small molecules will be produced as byproduct. And also nylon 66, terylene, bakelite, all these materials we have seen the synthesis, properties and applications. So this is the end of today's class. Thank you.